Okay, so let's talk about these index laws first, and we'll come over and discuss our scientific notation. So the law 1, I don't like calling it law 1, but it might come up every now and then, maybe in a quiz that we've got going on soon. Law 1 is the law of multiplication, which is some number to the power of m times the same number to the power of n. What do we think that law is, things like? What do you reckon the law is? Yeah. A is A still? A stays the same. A to the power of m plus n in brackets. So that's our law of multiplication. I like to put an example with these. I'll just give you one example. So if that was, say, 3 to the power of 4 times 3 to the power of 2, that would become 3 to the power of 6. Cool. The division law, a to the power of m divide a to the power of n. What's that law? Thanks, Alan.
M says n.
Yep, so a to the power of m minus n. Cool. With our example above, 3 to the power of 4 divide 3 to the power of 2 equals 3 to the power of 2. A to the power of m to the power of n. What do you reckon that is? Flip. A to the power of m to the power of n. What do you reckon that is? Have a guess. A to the power of m times n. You did know. Make sure we've got our brackets. Why do we need to make sure we put our brackets in for this? It's really important we put our brackets in. Yeah, so we do them first because according to Bomdas, it's going to do a to the power of m and then it will times your answer by n, which isn't quite the same, is it? Cool? The law of zero, the power of zero law. Get it? Anything to the power of zero is? 1. Can anyone explain to me why that's the case? Ashton?
Because you're not timesing anything by that 0, because there's nothing to times, and so you just have 1 and whatever.
Awesome. So if we look at this example, right? What happens if n equals m? So if we had here, instead of m, we had m. It would be a to the power of m minus? What's m minus m?
0.
We could represent that. So if I have 2 to the power of 2, or 3 let's say, divided by 2 to the power of 3, that's going to equal 2 to the power of 0, isn't it?
Yes.
But we also know that's equal to 8 divided by 8. $8, 8 friends, how many do they each get? 1. That's how the law works. Hey, Ella. Just don't recall asking for the iPad, just. Oh, sorry. I must have misremembered. A to the power of negative m. Ella, what do you reckon that is? What do you reckon it is? No idea. Well, what's law 2 say? Have a look at law 2 and then look at the negative power law. Oh, you could be onto something. Ashton, what do you reckon?
Is it m divide n?
So you m divide n. That is the division law, it's very close.
Like a divide n.
A divide n. Could be. I'll give you the hint. If we combine law 2 and law 4, let's have a look. That, so a to the negative m, is exactly the same as saying a to the power of 0 divided by a to the power of m, isn't it? Is it the same? What's a to the power of 0? 1. So wouldn't that be the same as 1 divided by a to the power of m? Now I've done this intentionally because that equals a to the power of 0 minus m, correct? What's 0 minus m?
M.
Is that the same as that?
No.
Is 0 minus m? Pick a number.
1, 6.
Whatever your number is, I don't care, right? Is negative that number equal to 0 minus that number?
No.
No.
So is negative 6 equal to 0 minus 6? Feels pretty equal to me. 0 minus 6.
That's 6.
That's a 6.
No.
0 minus 6 is negative 0 plus 6 would be 6.
He's got a valid point. So, what I'm trying to get at here is that this is the same as this, which is the same as that, correct? And we can represent that as 1 divided by 8 to the power of m, which looks like this as a fraction, doesn't it? So what have we done with our m? Yes, my hands are ugly. What have we done here? In your own language? You don't know? What's changed? Left hand side or the right hand side? The right hand side's a fraction, what's the power?
Positive.
So we make it a positive power and we flip it, put it in the denominator, correct?
Yeah.
That's the negative power law. Might come up, might not. It definitely comes up in senior, so it's a good thing to learn. 8 to the power of 1. Hey, very good. Anything to the power of 1 is just itself, correct?
Yes.
Atom to the power of 1 is out